This is Precalculus, Chapter 5, Lesson 5. I'm on page 363. All right, so we're going to talk about the properties and the laws of logarithms. Guys, we did this last year, but it's been a minute. And you've never worked this many problems or these hard of problems. All right, so it's going to feel harder. All right. But do you remember how we go between logs and exponents? What does this look like in exponential? What's my base? What's my base?
Y.
No.
X.
X is the base. To the C equals Y. All right, what does this look like?
E to the X equals Y.
No.
E to the Y equals X.
E to the Y equals X. Got it? All right, so when we're talking about logs, what's the log of 1 equal? Zero. Because 10 to the 0 power is 1. What's the ln of 1?
0.
0 as well. All right, what is the log of 10 to the 5th? It's 5. 10 to the 5th equals 10 to the 5th. Got it? What does the ln of e to the 6th equal? Because e to the 6th equals e to the 6th. This is called the argument, right? What is true about the argument? Do you remember? It must be yes. Greater than 0. Argument has to be greater than 0. It cannot equal 0 because I cannot raise any base to a power for it to equal 0. So that argument has to be greater than 0. All right. Now, I want us to, you have this so far? Can I erase? Okay, let's think about this. All right. Let's rewrite that in logs. So it'll be the log, what's my base? 10. To the x equals
Log of to the 10. Or I'm very confused. But it would be 10 because that's log.
well, yeah,
But
right.
is the 10 implied?
We don't have to write 10, right? Okay. So what does this equal?
X minus B.
Okay, let's put numbers here. Let's put numbers here. Let's say 10 to the log of 1. What does that equal? Right? Because we can do 10 to the log of 1. Can't you do 10 to the log of 1?
Yeah.
Yeah, do 10 to the log of 1 in your calculator. It equals what?
1.
It equals 1. So it equals not the log of it, but it equals v. There. It equals v. I wrote the log, but the log shouldn't have been there. So 10 raised to the log of an argument, it's the argument. That's all it is. Because what is this? The argument. Got it? All right. So let's do that with, what does that equal?
5.
Equals 5. The argument. Got it? You need to know these rules. Okay. Let's go over some more rules. That's the arguments. When the arguments are multiplied, it's the same rule as with exponents. Multiplication is?
Addition.
It's addition of the logs. All right? When the arguments are multiplied, you can add the logs. It is not when the logs are multiplied, you add the arguments. That is not what it is. It's multiplication here is addition of the logs. Got it? All right, division. What is division in exponents?
Subtraction.
Michael, you with us? Division is
Subtraction.
subtraction. Listen. When the arguments are divided, you can subtract the logs. All right? Now, raised to a power, we multiply. When the argument is raised to a power, it's the same thing as multiplication. Yes.
There's a problem with that on the homework. When I graphed it, it didn't come out the same.
Okay. We can look at it. All right. Does that make sense? Multiplication is, exponent is multiplication. There's actually one that is not in your textbook. It's how to change the base. It's actually in your textbook. It's just in the extra lesson that we're not covering. It's how to change the base. All right, so it's when you use this when the base is not 10. So you can make the base 10. All right? So A is your base and X is your argument. So it's the log of the argument over the log of your base. And you can make it a base of 10. You can change it to any base. This is how to change the base to a base of 10. You may need to know this in a future course. All right, so if I have the log base 16 of 32, how can I convert it to a base of 10? Log of 32 over log of 16, right? Okay, I want us just to remember something. How can I write that in exponential form? What is this in exponential form?
X to the 1/2, y to the 1/2. Or they keep the same.
Correct. X to the 1/2, y to the 1/2. All right. Let's walk through the examples. All right, look on page 364, common logarithms. The log of v is only defined when v is greater than 0. I said that, right? The log of 1 is 0. The log of 10 is 1. The log of 1 is 0. The log of 10 is 1. Got it? The log of 10 to the k equals k. We did that. 10 to the log of v equals v. We just did that, right? When you have a base raised to the log of any argument, the answer is the argument. When you have e raised to the ln of any argument, it's the argument. Got it? All right. So look at example 1. I work these different from your textbook, but is consistent with how we have worked them in the past. All right. So, because f of x equals e to the x is a function, if ln of x plus 1 equals 2, then e to the ln x plus 1 equals e squared. Okay, this is how they work them. All right, this is how they work them. I'm going to work them different. All right, got it? So they just made the base e on both sides, and this became the exponents. Got it? Can't you do that? You can do that, yes. And then all they did was set, what does this equal? X plus 1. They just said x plus 1 equals 2 and then solved. Or e squared equals e squared. They just said x plus 1 equals e squared. Got it? Because we know what this equals. Okay, that's not how I'm going to work it. Because I believe the other way is more profitable. Okay, we're going to convert this to exponents. We're going to get here, but it's easier. What's my base? E. What's my exponent? My exponent is 2. Got it? What does it equal?
X plus 1.
All right, did we get here? So you can do it this way, or you can go straight to an equivalent exponent.
Didn't we just do the same thing?
Yeah, it's.
No, we didn't. What did they do? They made e the base and put the equation in the exponents, right? You know what that is? That equals x plus 1 equals e squared. Well, you may need to know that. I don't think you necessarily need to know that. You do need to know you can take a base and make the equation the exponents. You also need to know that you can take the ln of both sides or the log of both sides. But if I have this, I can go straight to exponents, right?
So we're just skipping a step.
Skipping this step. I think you can go straight to exponential form. Okay, now I want to solve for x, so what would I do? Is that a real number on the left-hand side? Okay, well, give it to me. What is it?
6.389.
4 decimal places. Got it? 4 decimal places.
6.3891.
Right, exactly right. All right. Okay, so I want to show you something else. Guys, the log of 5 times 6, I'm going to say 30. You know, 30 is 5 times 6, right?
Correct.
Is going to be the same as the log of 5 plus the log of 6. Right? Right? It is. Actually, you could do that in your calculator. It really does work. We did it last year. Because multiplication is addition. Okay, let's go the other way. What does it equal?
Log of x squared plus x.
Because addition of logs is multiplication of their arguments. Got it? This is really x times x plus 1. All right, so we're going to go both ways. Got it? All right, so look at example 2. It wants the log of 33 and is given that the log of 3 is 0.4771 and the log of 11 is 1.0414. So is the log of 33 the log of 3 plus the log of 11? Yes, it is. So it's 0.4771 plus 1.0414. Do you understand that if I have a single log, I can break them out and it's multiplication is addition? All right, probably something exactly like this on your test, and people will miss it because they just won't add the 2 numbers I give them. All right, multiplication is addition of the logs. Okay, look at example 3. Example 3 is the quotient law. That one was the product law. Now this is the quotient law. Okay, if I want to find the log of 4, is that the same thing as the log of 28 over 7? Is that the same thing as the log of 28 minus the log of 7? Yes, it is. I'm sure that's the numbers they gave us. Example 3. All right, so the log of 4 equals, this is given, 1.4472 minus 0.8451. That equals the log of 4. Do you understand what we're doing? Does everybody understand so far? Yes! I'm so excited! Okay, so those are the foundations. Well, one more foundation. And then we're going to get into harder problems. Okay. Look at example 4. Is everybody with me on example 4? Right? We've done the product law. We've done the quotient law. We've done the quotient law. Now we're going to do the power law. All right? So in A, it's given that the log of 6 is that, I'll write it down, log 6 is 0.7782. What is the log square root of 6? Well, can I write square root of 6 in exponential form? What does it look like? The log of
6 to the 1/2.
6 to the 1/2. What's the power rule? A power is multiplication. So it's 1/2 times the log of 6. I know what the log of 6 is, right? Shh. It's 1/2 times 0.778 2. Got it? Everybody with me?
You can just put the log of square root of 6 in the calculator.
Oh, but you're not going to be able to do it when it's variables. And that's where we're going. So you have to know these rules. Okay? Look at B. Now we have the ln of 50 is 3.9120. What is the ln of the cube root of 50? Well, can I write the cube root of 50 in exponential form? What does it look like? Right, and what's the power rule?
Multiply.
1/3 times the ln of 50. This is the ln of 50. So it's 1/3 times 3.912. All right? Those are the basic rules. All right, let's look at example 5. Now we're going to use the laws to simplify log expressions. And then we're moving towards log equations and being able to solve them. All right? So look at this log expression. Can I write that as one single log? And I can. The first thing I do is do the power rule. All right, so this means this goes here. Got it? So we're going backwards, right? And you work left to right. Okay, so first I'm going to do addition. Addition of ln's is multiplication of the arguments. Right? All right. Subtraction is division of the arguments. So that's 3x to the 5th over 3xy. All right, now can I simplify that argument?
You may not want.
I may.
Sure.
That's 4. So it's the ln of x to the 4th over y. Got it? Correct. When you're doing the homework at home, exactly, right? Or actually until we get to the next few examples, because they do get harder. But, I mean, I told the Algebra 2 class today, guys, if you know the rules, then the harder problems shouldn't scare you. Just apply the same rules. Here's the problem. Here's what I see. There's a disconnect between the rule and your understanding and how to apply it. There is a disconnect. You're trying to memorize. This problem looks this way. This is what I do. And you cannot do that in your higher level maths. You cannot. You need to be able to look at a problem and apply the rules. Okay? All right. Look at example 6. We're going to simplify all right. All right, the first thing I want to do is I want to see if I can simplify the individual arguments before I do addition is multiplication. All right, so I can write the numerator as what?
X to the 1/2.
X to the 1/2 over X, right? And I can write this as
E to the 1/4.
e to the 1/4
X to the 1/2.
x to the 1/2. Right? Can I further simplify this?
Yes. Yes. Yes, you can. I mean, you could
Division is,
subtraction.
so this would be ln of x to the,
1/3. No.
what's 1/2 minus 1?
Oh, 1/2. Negative 1/2.
Negative 1/2.
Well, wouldn't multiplication be
Addition is
multiplication?
multiplication. I forgot that little negative. Can I combine my x's?
Wait, what? Oh.
I forgot my negative. How do I combine my exponents? Michael, you doing okay? How do you combine your exponents?
Addition.
Addition. What's negative 1 plus, what's negative 1/2 plus 1/2?
0.
What's x to the 0?
1.
Do I need to write that?
No.
So what is this? ln e to the 1/4. Okay, wait just a minute.
Oh. No, don't celebrate yet.
I have a power.
Wait, yeah, this is really sad.
I can move the power to the front.
Oh.
Wait,
No.
I can put this in my calculator. Wait just a minute, don't do it.
Oh, good.
Right here, everybody look. What's the ln of e?
And E. 1. 1.
1. What does this equal?
Oh, yeah.
You could have known that here.
No.
It's one of the rules. Yeah. Look, guys. All of this. You know what it equals? It doesn't matter what x is. It doesn't matter what x is.